In a Y-service configuration, the neutral conductor plays a crucial role in the grounding system. Specifically, the neutral conductor functions as the grounding conductor. This means it provides a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. The practice of using the neutral as the grounding conductor is permitted under specific conditions outlined in the National Electrical Code, or NEC. It's essential to understand these requirements to ensure a safe and compliant electrical installation. The NEC addresses grounding and bonding requirements extensively, and adherence to these rules is paramount for safety and proper system operation. Bonding is a critical aspect of electrical safety. It involves connecting conductive parts of an electrical system to create a low impedance path for fault currents. This ensures that all exposed metal parts are at the same electrical potential, minimizing the risk of electric shock. In a Y-service, the neutral conductor is bonded at two key locations: firstly, at the transformer supplying the service, and secondly, at the service equipment. Bonding at the transformer ensures that the neutral is effectively grounded at the source. This connection establishes a reference point for the electrical system and helps to stabilize the voltage. Bonding at the service equipment, typically the main service disconnect, provides a direct path for fault current to return to the source from any point within the electrical system. The connection is typically made to the metal enclosure of the service equipment, effectively grounding all metallic parts. When the neutral conductor is properly bonded at both the transformer and the service equipment, a separate equipment grounding conductor, often referred to as an AGC, is generally not required. The neutral conductor provides the necessary path for fault current, and the bonding ensures that all metallic parts are properly grounded. However, there are exceptions to this rule. The NEC specifies situations where an equipment grounding conductor is required even when the neutral is bonded. These situations typically involve sensitive electronic equipment or areas where increased safety is desired. For example, in healthcare facilities, additional grounding measures are often required to minimize the risk of electrical interference and ensure patient safety. It's important to consult the NEC and local electrical codes to determine the specific grounding requirements for each installation. Understanding the difference between grounding and bonding is essential. Grounding refers to connecting an electrical system to the earth, providing a reference point for voltage and a path for fault current. Bonding, on the other hand, refers to connecting conductive parts of an electrical system together to create a low impedance path. While grounding and bonding are distinct concepts, they are closely related and both play a vital role in electrical safety. The neutral conductor in a Y-service provides both grounding and bonding functions. It is grounded at the transformer and bonded to the service equipment, effectively grounding the electrical system and providing a low impedance path for fault current. When installing a Y-service, it is crucial to follow the NEC guidelines for grounding and bonding. This includes using the correct size conductors, making proper connections, and verifying the grounding system's integrity. Improper grounding or bonding can create hazardous conditions, increasing the risk of electric shock and equipment damage. Therefore, only qualified electricians should perform electrical work. Grounding electrode conductors, or GECs, connect the grounded conductor, or neutral, and the equipment grounding conductors to the grounding electrode. Common grounding electrodes include metal underground water pipes, metal frames of buildings or structures, concrete encased electrodes, and ground rings. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the GC based on the size of the service entrance conductors. The grounding electrode conductor must be securely connected to the grounding electrode using approved methods. These methods include exothermic welding, listed pressure connectors, and other methods specifically permitted by the NEC. The purpose of the grounding electrode system is to provide a low impedance path to earth for fault currents. This helps to stabilize the voltage in the electrical system and reduce the risk of electric shock. A properly installed grounding electrode system is essential for the safe and reliable operation of an electrical system. Equipment grounding conductors, or AICs, provide a low impedance path for fault current from the metal enclosures of electrical equipment back to the source. This helps to ensure that overcurrent protective devices, such as circuit breakers and fuses, will operate quickly in the event of a fault. EGC can be either wires or metallic raceways. When wires are used, they must be insulated and identified with a green color or green with one or more yellow stripes. Metallic raceways, such as metal conduit, can also serve as EGC, provided they are properly installed and meet the requirements of the NEC. The size of the equipment grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. The NEC provides tables that specify the minimum size of the EGC based on the rating of the overcurrent protective device. It is essential to properly install and maintain equipment grounding conductors to ensure the safety of electrical equipment and personnel. Bonding jumpers are used to connect metal parts of an electrical system together to create a low impedance path for fault currents. Bonding jumpers are typically used to bond metal enclosures, metal raceways, and other metal parts of an electrical system. The size of the bonding jumper is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size of the bonding jumper based on the size of the circuit conductors. Bonding jumpers must be securely connected to the metal parts using approved methods. These methods include exothermic welding, listed pressure connectors, and other methods specifically permitted by the NEC. The purpose of bonding jumpers is to ensure that all metal parts of an electrical system are at the same electrical potential, minimizing the risk of electric shock. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electric shock. GFCIs work by monitoring the current flowing in the circuit and detecting any imbalance between the hot and neutral conductors. If an imbalance is detected, the GFCI will quickly trip the circuit, interrupting the flow of electricity and preventing electric shock. GFCIs are required in many locations, including bathrooms, kitchens, and outdoor areas. The NEC specifies the locations where GFCIs are required. It is important to install and maintain GFCIs to protect people from electric shock. Arc fault circuit interrupters, or FSIs, are devices that are designed to protect against electrical fires. FSIs work by monitoring the current flowing in the circuit and detecting any abnormal arcing conditions. If an arc is detected, the FSI will quickly trip the circuit, interrupting the flow of electricity and preventing a fire. FSIs are required in many locations, including bedrooms and living rooms. The NEC specifies the locations where FSIs are required. It is important to install and maintain FSIs to protect against electrical fires. Surge protective devices, or SPDs, are devices that are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other events. SPD work by diverting the surge current away from the electrical equipment and back to the source. SPD are available in a variety of sizes and types, and they can be installed at the service entrance, at branch panels, or at individual pieces of equipment. It is important to select and install SPD that are appropriate for the specific application. Regular inspections and testing of electrical systems are essential for ensuring safety and reliability. Inspections should be performed by qualified electricians who are familiar with the NEC and local electrical codes. Testing should be performed using appropriate test equipment to verify the integrity of the grounding system, the operation of GFCIs and FSIs, and the overall condition of the electrical system. Regular maintenance, such as tightening connections and replacing worn or damaged components, can help to prevent electrical problems and extend the life of the electrical system. The NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years, and it is important to stay current with the latest edition of the NEC. The NEC covers a wide range of topics, including wiring methods, grounding, overcurrent protection, and equipment installation. The NEC is not a law, but it is widely adopted by state and local governments. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. Local electrical codes are often based on the NEC, but they may also include additional requirements that are specific to the local jurisdiction. It is important to be familiar with the local electrical codes in addition to the NEC. Local electrical codes can be obtained from a local building department or electrical inspector. When working with electrical systems, it is important to follow all safety precautions. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Never work alone. Be aware of the potential hazards of electricity and take steps to minimize the risk of electric shock or fire. Electrical work should only be performed by qualified electricians who are familiar with the NEC and local electrical codes. If you are not qualified to perform electrical work, hire a licensed electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to ensure safety. In summary, when dealing with a Y service, understanding the role of the neutral conductor as the grounding conductor is crucial. Proper bonding at the transformer and service equipment is essential for safety and compliance with the NEC. While a separate equipment grounding conductor may not always be required, it's important to consult the NEC and local codes to determine the specific requirements for each installation. Always prioritize safety and consult with qualified electricians when working with electrical systems.